This Headless Professor video is about frequency distributions. We're going to start off talking about a histogram. A histogram is like a bar chart, and it's used for looking at the distribution we have with discrete variables. In this particular case, we see the scores down here on the bottom in red. This shows that no one scored a 0. One of our cases scored a 1, 2 cases scored a 2, 3 cases scored a 3, nobody scored a 4, and one person scored a 5. If we have a continuous distribution, we can use something that looks more like a line graph. This is known as a frequency polygon. A frequency polygon and a histogram are both univariate distributions. They tell us how a particular variable is distributed. So even though we have an x-axis, which is horizontal, and a y-axis, which is vertical, we don't have a bivariate distribution. They're telling us two different things about one variable. The horizontal axis looks at the score. The vertical axis looks at the frequency. Some frequency distributions are flat. Everybody gets the same score. This is usually found in theoretical distributions where we assume a kind of classical probability. What we're going to focus on here today is the normal distribution, also known as the Gauss curve, because it was discovered by the German mathematician Gauss over 200 years ago. The normal distribution can also be known as the standard curve or z-curve, especially when the mean is set at 0 and the standard deviation at 1. The normal curve is symmetrical. The left half of the curve looks like the right half of the curve. The normal distribution is unimodal. In other words, the mean equals the median equals the mode. This is what the normal curve looks like. It has a hump in the middle and very narrow tails at each end. This is what a bimodal curve would look like, with a lot of scores at a certain low point and a lot of scores at a certain high point. Obviously, the bimodal curve would not fit the Gaussian criteria. This is a Gaussian curve, but it has extremely high kurtosis. One big hump in the middle and then two very small tails. This would be the opposite of that. This curve would also meet our Gaussian criteria, but it's called heavy tails because it has low kurtosis. This is a non-normal distribution known as a right skew. What this says is that we have a few very high scores that are not counterbalanced by comparable low scores. The right skew is encountered very frequently, especially if we look at such things as incomes, where very few people make a very high amount of money. This would be an example of a left skew, where our distribution has a few extremely low scores. This is a right truncation. That means that we've sort of lost the right tail of our distribution. This is usually found when we have something that imposes a ceiling on the scores. Perhaps the test that this variable represents was a very easy test, and most people scored close to the top. This is a left truncation. This occurs when we have some kind of floor, and as a result we don't have our left tail. This occurs when our sample has been created by some sort of qualifying exam, and you simply cannot get into the sample unless you score a certain minimum amount. This has been another Headless Professor video, this one on frequency distributions.